All right, so welcome to part two of expanding the expression. So here we're going to have negative 2.5 parentheses negative 3 plus 4n plus 8. Okay, well, I can see here, of course, we can always start off by multiplying or distributing the 2.5, the negative 2.5 rather, to every term on the inside. That's called obviously the distributive property, but we don't have to. I can see here that there are like terms. The first thing I can do is add what's inside the parentheses that is like terms, or subtract. So I have negative 3 plus 8. That's going to give me 5. So I'm going to have negative 2.5, 5 plus 4n inside the parentheses. And now I can distribute the negative 2.5 to each of the terms inside of the parentheses. So we're going to have negative 2.5 times 5 plus negative 2.5 times 4n. Okay, and now we just have to simply do whatever negative 2.5 times 5 is, which is negative 12.5 plus, and now we do 2.5 or negative 2.5 times 4, which is going to give us negative 10. And we can't forget about the n there. And we see here that we have a plus and a minus, so those two, it kind of looks like a happy face there. Those two are going to change to strictly a negative. When a positive and a negative multiply, we get a negative. So we're going to have negative 12.5 minus 10n, or negative 10n minus 12.5. All right, our second problem is a little bit easier than that. We're not really doing any mathematics, but when we multiply or distribute a variable to every term inside the parentheses, we're just basically multiplying, but we're just giving it a y, essentially. So what that looks like is, of course, we're multiplying, so we're going to have y times 9, right? First term, we're going to multiply by 9, and then we multiply the y by negative 0.2, so we're going to have plus y times negative 0.2x. And so that first term here with the y and a 9 will be just 9y plus, and when we multiply y to negative 0.2x, we just get negative 0.2xy. And again, we see the same positive negative that we saw in the first example here, and that's just going to turn into a negative. So we're going to have 9y minus 0.2xy, and that will be the answer for this one. All right, so now in this case, again, we have something similar. We could multiply the half to everything inside of the parentheses, but I do see that we have some like terms, that is the 3 and negative 10. When I subtract 3 minus 10, I'm going to get negative 7, so we're going to be left with half parentheses negative 7 plus 4t. And now there's nothing else that's like terms, so we can go ahead and use the distributive property. We're going to do half times negative 7 first. So half times negative 7, and then plus half times 4t. So we have half times 4t. Okay, the negative 7 times the half, or the half times negative 7, is just going to be negative 7 over 2. Plus, and half times 4t is going to be just 2t. And this is our final answer for the second problem. Now again, you could use the distributive property to multiply the half by everything inside the parentheses, or see what's like terms. Always ask yourself, can I combine anything inside? If there's like terms, you certainly can, and then use the distributive property afterwards to multiply what's outside the parentheses to everything inside the parentheses. So the third problem here, or the fourth problem, I should say, same thing. Do we have anything we can combine inside the parentheses? Well, yes, we can. We have two like terms, the two numbers here. So that's 15 minus 5. That's going to give us just 10. So we're going to have 1/5 parentheses 10 plus 10x. Nothing else with the x, no other like term with x. So now all we have to do is multiply the 1/5 to everything inside the parentheses. As always, I like to write my multiplication first so I know what I am multiplying. And just in case we get like a negative, I'll see whether we can, use any multiplication rules to multiply. We have first the 1/5 times 10 plus 1/5 times 10x is the second term that we're going to be multiplying. And now we just simply multiply. So 1/5 times 10 is just going to be 2 plus, and the same thing, 1/5 times 10x is the same thing as what we just did. And that will be 2x. We bring back that x, obviously. And that is the final answer here. So the biggest thing we saw here was just using, or at least combining like terms first inside the parentheses, and then using the distributive property to expand the expression. It's just less multiplication you can do. You can obviously certainly multiply without having to combine any like terms, but then you'll end up just multiplying more things than you should.